Hello everyone. I welcome you all for today's session for the implementation of Boolean function using CMoS static logic and to draw its stick diagram. We are being given up with this particular Boolean function y equal to a dot b plus c plus d into e. Right? Since we are having 5 number of inputs, I have to take 5 number of PMOS transistor and 5 number of NMOS transistor. This PMOS will function as pull-up network, whereas the NMOS will function as pull-down network. Right? As discussed already in our MOS transistor as switch, whenever the NMOS transistor are in series, it performs multiplication operation, and NMOS transistor are in parallel, it performs the addition operation. Okay, so just contradict to that, when PMOS connected in parallel, it perform the product. Okay, so this one we have seen in the previous video, that is drawing the logic diagram for the given function. Right? So in this, what we have done here in the sense, I have marked the source terminal and the drain terminal of all the 10 transistors we are utilizing. Very simple is that in PMOS transistor, always the source terminal has to be tagged with the supply, and similarly in our NMOS transistor, the source has to be connected to the ground. Okay, so if this is source, this would be drain. If this is source, this would be drain. Likewise, we have to mark down the gate, source and drain of all the 10 transistors. Right? And then before getting into the stick diagram, we have to make down the Euler's path. So for what it is being considered in the sense, since we are having 10 number of transistor, we should not be at a confusion. Okay, or we should not leave any one of the combination. Okay, connection should not be missed out. Okay, so this Euler's path help to perform an uninterruptible path. So for example, if you take down this PMOS transistor, if I start from this transistor C, okay, I am moving from drain to source of C transistor, then I will be moving to B, then A, and then D, E, and I will be coming back to C. Okay, the path is not at all interrupted. The same way, if I look at the NMOS transistor, I can move from this drain to source of C transistor, B transistor, A transistor, and then D transistor, followed by your E transistor. Therefore, here the Euler's path is going to be C, then B, followed by A, D, and E. This is the Euler's path for this logic diagram. That is, for the schematic diagram, we consider C, B, A, D, E as the Euler's path. Right? Now, coming to the stick diagram. First, we have to draw down this VDD and ground. Okay, so which is blue color. Okay, we have to connect this supply VDD and ground some way apart, so that we have to accommodate the remaining components within that. Clear? Next, this yellow color indicates P diffusion and green color indicates N diffusion. Okay. Next, I have to draw 5 number of transistors, 5 number of polysilicons. In which order? It is not mandatory, but we can follow this Euler's path C, B, A, D, and E. Okay, so if a polysilicon lies over diffusion, that will function as a transistor. Therefore, this is one PMOS transistor, this is another PMOS, this is one another. Likewise, I am having 5 number of PMOS transistor. Similarly, if the polysilicon lying over the green color, that is N diffusion, it forms the NMOS transistor. So 5 number of NMOS transistor we have drawn. Okay, and we have marked the input C, B, A, D, E, everything. And here we have marked down the source, drain, right? Everything we have to mark, taking down the path from C, B, A, D, and E. The first terminal is drain. Okay, that drain has to be mentioned here. Then the source of C is connected to drain of B. Okay, parallelly you can look at the schematic diagram on the left hand side. Right? The source of B transistor is connected to source of A transistor. The drain of A transistor should be connected to source of D transistor. The drain of D transistor and drain of E transistor are connected together, right? And then finally we have to connect this connection, source of E transistor to the drain of C transistor. Okay, and one more connection is drain of A transistor to be connected with drain of C. Okay, now you could see this is the drain of A and this is drain of C. So both the things I have just connected by a metal contact. That metal contact should be connected to source of your E transistor. Okay, that has to be connected to source of your E transistor. Since I am having more than two sticks of different materials, I have to indicate the contact. Okay, electrical contact by a black color dot. Right? Similarly, coming to the NMOS transistor. Again, I have to move down from drain source of C transistor to B, A, D, and then I have to come back to E. So I am starting from drain to source. You could see drain terminal of C transistor, source terminal of C transistor. Right? That source has to be connected to source of your B transistor. Okay? The drain of your B transistor should be connected to drain of your C transistor. Sorry, A transistor. Okay? The drain of A transistor and drain of D transistor has to be connected. Source of D transistor and drain of E transistor has to be connected. This source is grounded. Okay, and moreover you could see the source of B transistor, the source of C transistor are interlocked. Source of B transistor and source of D transistor are being interlocked. C and B, both the sources are shorted together. This also will be coming up to this supply, that is your drain. Okay, here I have to draw down the ground connection. Okay, then we have to take the output from drain of D and E of your PMOS transistor. In between D and E of your PMOS transistor, drain of D and E, I am just making a metallic contact so that a blue color metallic contact is made in order to measure the output Y. Similarly, the drain of A transistor and D of your NMOS has to be shorted, right? Drain of A transistor and D transistor. This is the point. From here, I am taking a metal contact. Okay, both are interconnected, and then I have to come and extract the output. Since this is the two stick of same material, need not to mention the electrical contact over here. But whereas here, this is two sticks of different colors. This is metallic contact, this is N diffusion. Therefore, I have to indicate the electrical contact by mentioning by black color dot. Right? Similarly, this source and ground are of different material. Therefore, it has to be made an electrical contact. The same way here also. Right? So, hope you understand the stick diagram for any given function. Okay, depending upon the input, you have to draw down the polysilicon material. So it is better, it is advisable to indicate the terminals, what are the source and what are the drain, how they are going to be interconnected. So if you are following this Euler's path, it will be easy for you while making the interconnection, so that more number of wires can be reduced, the length of the wires can be reduced, and moreover our stick diagram looks very simple and lucid. It gives a clear topographical and layer information of what exactly the logic function is being performed. Okay, so actually this y equal to a dot b plus c plus de whole bar is nothing but CMOS XOR gate. Okay, we have implemented the CMoS XOR gate by means of CMoS static logic, and then we have obtained the Euler's path in order to obtain the uninterrupted path, and then we have done with the stick diagram for this. Right? Hope you understand this session. Thanks a lot.